Welcome to IB Math Center. This is question number 4, part A and B of the Geometry and Trigonometry series, booklet 3. For those of you who are here for the answer to this question, for part A, we had to show that the value of the angle at Y is 70 degrees. The answer to part B, the value of X is 40 degrees, and the value of V, which is part C, is 31 units. Right, for those who would like to look at the solution, feel free to pause your screen here, and let's move to the explanation step. So the following diagram explains the use of sleeves for paper cups. Hot beverages are commonly served in a paper cup. Cardboard sleeves are used to reduce the discomfort when the sleeves is unfolded. So that's all the build up to the question. In this question, we will make calculations to find the area of the sleeve and consider the amount of cardboard wasted in their production. Okay, we have a diagram, a figure that's given to us, and we have to show that the value of angle at Y is 70 degrees to the nearest degree. Right, if I zoom in, so that's my angle Y, and I see that this is a this line, this dotted line here is perpendicular to the solid line. And I know that the distance from this perpendicular bisector to here is 12.55, and from this dashed vertical line to this dashed vertical line it's 10.6. So then one can argue that this distance is 12.55 minus 10.6, which would equal to 1.95. And I do notice a triangle here also, a right angle triangle, right? This is 90 degrees. This is 5.7. That's given to us. This side is 1.95. We've just calculated, and we are to find this angle Y. So one could argue that Y, because it's a right angle triangle, so we could use trigonometric ratios, and we know the base and the hypotenuse, the angle, the side that's right opposite to the 90-degree angle, that's the hypotenuse, right? So we know the base, we know the hypotenuse, we can easily find the angle using cos function. So cos of the angle Y would be base, which is 1.95 divided by, 5.7. So the inverse, the cos inverse of 1.95 divided by 5.7 will give me 70 degrees. So that's the first part, right? We're able to show that the value of the angle is 70 degrees, right? Hence determine the value of the angle at X. Now that's the second task at hand. So if Y is 70, this side would also be 70 because this perpendicular bisector exactly halves the diagram into two equal parts. You can see 12.55, you can see 12.55. So this would be 72, 70 as well. So we've got a triangle in which two of the angles are 70. What would be the third angle? So we know the unknown angle X plus 270s should add up to 180. 70 and 70 is 140. So x plus 140 is equal to 180. 140 is adding here. It would go there and subtract. So the angle x is 180 minus 140, which is equal to 40 degrees. Right. Okay. One could also, no, you can't use trigonometric ratios because we don't know the value of v at the moment, right? Hence calculate, no, that's not hence. So we have to calculate the value of v. So we know that x is 40 and we do see a vertical line. If we extend this vertical line, it should split the angle into two identical parts. So this would be 20 degrees and that part would be the remainder 20 degrees. Now we have a right angle triangle. Let me just draw this big right angle triangle. Where we know that this angle is 70. We know here we've got 20. We've got a 90-degree angle here. This side is 12.55. We can easily calculate this side. We could use this angle and a trigonometric function, or we could use 70 degrees. Let's just stick with 70 degrees. So cos of 70 is base, which is 12.55 over hypotenuse. So cos of 70 is 12.55 divided by the hypotenuse. So the hypotenuse would be 12.55 divided by cos of 70, and cos 12.55 divided by cos of 70 gives me 36.7. So if this entire length is 36.7 and this part is 5.7, you can see 5.7. So subtracting 5.7 from 36.7 should give us V. So V is 36.7 minus 5.7, which is 31. So I hope you were able to get the solutions, you were able to understand them. If you still have questions, please feel free to let us know and join IBMC.